Hi everyone. Today we're going to talk about two concepts here, evaporation first and then condensation. Okay, so as we move through this, I want everyone to make sure they're remembering that if we increase kinetic energy, that is going to cause the particles to move faster with more energy, and that is going to lead to a decrease in IMFs. Okay, so if we increase kinetic energy, that's going to decrease the IMFs, and this decrease in IMFs will lead to phase changes. Okay, so I want everyone to think, what is vaporization? So think about if something vaporizes, what is it doing? And so hopefully you've realized that this would be a liquid becoming a gas, right? So if something's vaporizing, the liquid is going into the gas phase or the vapor state, right? Now I want you to think about what is evaporation. If you had a glass of water sitting outside on a hot summer day, what would happen to the level of water in that glass? Yeah, it would decrease. So what's happening to the water? Some people say it's disappearing. Well, it's not disappearing, it's just changing states, right? So evaporation is also a liquid going to a gas or becoming a gas. So looking at these, now these both of these things are true, but they're different words, right? So what's the difference between those two things? So I want you to really come up with an answer. What's the difference between vaporization and evaporation? Sometimes people will say, well, maybe it's because, or evaporation is caused by the sun. And that's not the right answer. I mean, it's a good guess, but let's talk about it here. Okay, so we've got this little picture. We've got some nice birds in the sky, some flowers growing. We've got our sun with the sunglasses. Now, the sun is got rays, right, that are coming out. So the sun's energy is coming towards this glass of water here, this drink me glass of water. Now, if we look at, actually, let's go blue. The glass of water, now, if this is out in a hot summer's day, for example, it is going to, the water level is going to decrease, right? So my question is, which particles are going to evaporate? We know that the water is going to evaporate, but which particles specifically? So is it going to be a particle down here that evaporates? So at the bottom of the glass, is that the one that's going to turn into the gas phase? Or is it one sitting right at the surface of the liquid? Which one do you think is going to evaporate? Good. And hopefully you've come to the conclusion that it's most likely going to be this one, the one at the surface here, that is going to leave the system. So it's going to gain enough energy from the sun. So this is our energy coming from the sun, and that particle is going to gain enough energy that it will break the IMFs down, change phases, or change states into the gas state, and then leave the system. Okay, so evaporation we can define as when vaporization occurs only at the surface of the liquid. So evaporation always happening at the surface. Okay, so question here, what evaporates faster, alcohol or water? Now, we know that not all liquids will evaporate at the same rate. There's differences, and we know that just from our real life here. So, for example, alcohol versus water here. They evaporate at different rates, and that's because they have differing IMFs. Now, in this particular unit, if you're ever at loss for an answer and you don't know what it is, guess IMFs, because IMFs, intermolecular forces, are responsible for a whole lot of stuff in the properties, when looking at the properties of matter here. So looking at alcohol versus water, which one's going to evaporate quicker? Okay, so hopefully you have, and some of you will just have had experienced this in your real life. Alcohol is going to evaporate quicker. Now, substances that evaporate quickly are called volatile, and they have very low IMFs. So alcohol has IMFs that are lower than, or not as strong, or weaker, I guess I should say, than water. Has anyone ever had, some of you have had rubbing alcohol. So rubbing alcohol on your hands. So some people, when they get a cut, they'll clean it with rubbing alcohol. How does this same would be true for if you were using nail polish remover. Some of you have had acetone with it. Some of you have had experience with that. So how do these liquids feel on your skin? And some of you they feel cool to the touch, right? So have you ever thought about why they feel cold? I mean, they're sitting at room temperature, right? They shouldn't be any colder or warmer than anything else, right? So why do they feel really cold? And the reason for that is that they're volatile, so they are going to evaporate very, very quickly. So you get a sensation of feeling cool because they're leaving your skin surface very rapidly, and then when the air hits the surface of your skin, you get the sensation of it being cool. Okay, now we're going to draw a little diagram here. This is our water. So we're going to have a particle. And so the one that's colored in, these are all water particles in here. The one that's colored in is at the surface, okay? So this is just to sort of explain the evaporation thing a little fuller here. So this particle is going to collide with other particles. And so things that are in continuous random motion, that's what kinetic molecular theory states, they're going to collide, right? So this particle may gain enough energy to become a gas. So when it becomes a gas, it's going to leave the system. Now, sometimes, just so you know, it can collide because there's air particles sitting up here. So it can collide with other air particles and then lose energy and get pushed back into the system. That does happen sometimes. But this particle at the surface is likely going to leave the system as a gas when it gains enough energy. Whoops. Now, again, we're going to draw our particles, but now we're going to be talking about a particle at the bottom here. When the particles are not on the surface, there are more particles and therefore greater IMF. So remember, this particle is surrounded by other water particles, all of which have hydrogen bonds between them, which is a type of intermolecular force, so IMFs. So we've got lots of IMFs around this particular particle, so that would be holding it in the liquid phase. Now, if that particle does happen to absorb enough energy to phase change, on its way up, it is going to collide with other particles, likely. And when it does that, it's going to lose the energy and will be pushed down and become a liquid once again. This is why evaporation is a surface phenomena. So we've got clothes on a clothesline drying. Some of your families may do this. So when we leave clothes to dry, the water is going to evaporate out. Now, if you had a towel that you bunched up in a ball, and your parents would give you trouble for that, no doubt, is that water going to be able to evaporate? No, and because it's a surface phenomenon. So if you want something to dry quickly, you're spreading it out, right? You want more surface to be available, which leads us to our next point. If the surface area is increased, we increase the rate of evaporation. So evaporation only happens at the surface. So if we increase the surface area of something, it evaporates quicker. Now I've included a picture here of one of those almost old-fashioned hand dryers now. We don't find them all the time anymore. And if you look here, it's kind of hard to see, but that is an image of hands. So it'd be like 1, 2, 3, 4, 5 fingers. Oops, my pinky's a little odd. And it shows your hand moving, okay? So the directions on these types of hand dryers, you're supposed to rub your hands together. So rub them together as you're drying them. Did you ever think, why did you have to do that? And the reason, of course, is that as you're rubbing your hands together, you're spreading the water out, so you're increasing the surface area of the water, and so it's going to evaporate quicker. So that's why we do that. Okay, so at the surface, we have a couple things happening here. We've got both evaporation and condensation happening. And so we can talk about those other words for those would be escape and recapture here. Okay, so we've got the escape, particles coming out, and then we've got the recapture of them going back in. So we're going to talk about this here. So this is in an open container here. So if the rate of evaporation is greater than the rate of condensation, what's going to happen to the level of water here? Yeah, the level of water will decrease. So, you know what, I should, instead of water here, let's put the liquid. The level of liquid will decrease here. So if the rate of evaporation, so if the particles are evaporating, so changing into the gas phase at a higher rate than they're condensing back into it, the level of the liquid is going to decrease. And this would be in an open container here. Now, in a closed container, now we put a lid on it. Eventually, if you leave this here, eventually, the rate of evaporation, I'm just going to abbreviate that to evap, will equal the rate of condensation. Oops. So the rate of evaporation will equal the rate of condensation. And in that case, will you see that water level decrease? No, you will not. So you will have achieved an equilibrium, and this is called, and we call this dynamic equilibrium. So dynamic equilibrium, and we call it dynamic because something's always happening, okay? So dynamic equilibrium. So looking at this container sitting on a shelf, for example, if we looked at this flask on a shelf, you would not see anything happening. It looks like nothing's happening. However, it has just reached dynamic equilibrium. So the rate of evaporation has been equal to the rate of condensation. So it looks like nothing's happening, but it's always important to know that if you had a microscope and you really can get in there, something is usually happening. Your assignment for this one, you just need to think about this question, and then we'll talk about it when you're in class next. So what would cause the level of a liquid in an open container to stop dropping? So what I mean by that, say you've got a glass of water. What would cause that level to stop dropping? Because if we just leave it sitting out, eventually that water is going to evaporate, right? So what could cause it to stop dropping? So think about that. Okay, thanks everyone.